Well, and welcome to the Daily Space Weather, the world's most comprehensive daily space weather show and the most detailed imagery you'll find of the closest star. Thanks for stargazing with us. Today's story is massive numbers of plasma filaments. You might see a solar polar vortex forming there around the southern polar region. Some flaring of the M-class variety, coronal mass ejections, and new sunspots. Let's take a look at the last thing I've stated first. New sunspots. So there's another one that rose in the northeast. That'll be 3425 or 3426. One also formed in the northwest. So right up here you can see another sunspot forming over there. The main activity has come from these groups that are near the equatorial portion of the solar disk. And fun fact, folks, that's a triple F, fun fact, folks, around solar maximum we see sunspots at all latitudes. So we see high and low latitude sunspots, meaning sunspots closer to the poles and sunspots close to the equator. Here's the southern hemisphere, and we're going to show you some more detailed imagery of that solar polar vortex that happened down there. A bunch of plasma looks like it has either collapsed or perhaps even ejected there. I think it's all collapsed. You'll see it encircling the southern polar region, and then a bunch of it splashing back down toward the chromosphere. By the way, if you enjoy the content, don't forget to press that like button. Do yourself a favor and get the daily space weather show delivered right to your subscription feed. Press that subscribe button, press share, etc. Thanks to our new subscribers, and congratulations on realizing that the channel exists. We are the least busted name in news, the Smash News Network. Take a brief look at sunspots here. Again, a new sunspot formed right over here. Also, a new one rose up here. So, major solar uptick in progress. Here is the SDO magnetogram that depicts yesterday plus today. The previous videos we showed you in 171 angstroms, those were 24-hour videos. And let's move on to volcanoes. Shishildin, an Alaskan volcano, has erupted in a spectacular fashion and produced a 32,000-foot plume of volcanic ash. That is first on our list. Uluwun, also on the list. It's produced a 9,000-foot ash plume over New Britain, Papua New Guinea, as it explodes. It's a flight level 090. Semeru, flight level 140 as it explodes. It's located on East Java, Indonesia. Tokono exploding. Flight level 080 over Halmahera, Indonesia. And then Shishildin, yes. 10 days since the latest paroxysm, and kablooey, 32,000-foot ash plume was created. Pretty intense activity there in the Aleutians at Shishildin. Popocatépetl exploding, flight level 210 over central Mexico. It's a 21,000-foot ash plume. Sabancaya, not sure if it's erupting. Don't assume it's not. Please do not pole vault the caldera. Last but not least, Erta Ale. They thought it was going to start blowing up some lava fountains, but it really hasn't happened. It's just been kind of undulating. The pit crater appears to be stable, characterized by the ongoing equilibrium between heat, magma, and gas steam emissions, supply, and loss. Next, seismic activity. Our viewers want to know what's shaking, so we cover it. We'll call out quakes of a 5 or greater magnitude. That's a 90-day bar graph from volcanodiscovery.com, and moving to the USGS site. Again, we'll call out quakes of 5 or greater magnitude. Starting out with this 5.0 at Indonesia. That was at 14:58 Universal Time yesterday afternoon. And then only 5 minutes later, a 5.8 strikes Papua New Guinea. That was at 15:03. And then less than an hour later, a 5.2 strikes Tanzania there on the opposite side of the Indian Ocean. That was at 15:42. Then at 17:50, a 5.0 strikes north of Ascension Island. That's the second 5+ magnitude quake in that region over the past 48 hours. And what else do we have? Anything else of a 5 or greater magnitude? Nope, that's it. Which means it's time to head back to space. So here is the SDO 304 angstroms wavelength, one of the classic wavelengths, and eyes on that southern polar vortex region there. I think that plasma just splashed back down. We see multiple brightening events known as Hyder flares as that plasma looks like it has succumbed to gravity and moved back down toward the chromosphere. We'll let that play through one more time, and we've got some extreme close-ups of that in our filament section, which is right after we'll cover coronal mass ejections. The 10.7 centimeter radio flux has moved up quite a bit here to 143 solar flux units, a more reasonable number. As we are only about a year away from solar maximum, there is the 1-year graph of the radio flux represented by that black line. The red line is the sunspot number, which will continue to climb. Again, 2 new sunspot groups will get named today. We'll show you close-ups of those momentarily. Also, NOAA expecting a high-speed coronal hole wind stream. So we did see some unexpected geomagnetic unrest yesterday. It looked like a minor CME impact. And we are expecting a possible minor CME impact today as well. So we forecasted that about 3 days ago on September 3rd. Anyway, that's the current situation from the Space Weather Enthusiast dashboard here. NOAA was expecting some geomagnetic unrest this morning. It hasn't happened yet. Again, it is from a coronal hole high-speed stream as well as coronal mass ejection influences. Next, we'll look at Earth's magnetic moment from space for the past 4 hours. That is our geospace magnetosphere movie. Solar wind coming in from the left. That's the daytime side of the planet. Magnetotail on the right, the nighttime side of the planet. And things are pretty homogeneous and geomagnetically calm here for the past 4 hours. Earth's magnetic moment from the ground for the past 4 hours is looking like this. This imagery will show you the most likely places to see the aurora, telluric currents, pipeline, railway, and power grid induction. It's our ground magnetic perturbations map. It depicts geospace delta B. That's the changes to Earth's B field for the past 4 hours. The units here are nanotesla magnetic flux density. And again, we are in a geomagnetically calm condition at the moment, which could end suddenly if the CME impact that we forecasted does show up. Currently, it's 2.33 for the planetary K index. KP 2.33 is the global geomagnetic average. And looking at the real-time solar wind, here's this little impulsive CME impact that happened yesterday. Right in here, we saw a change in the plasma temperature, a double shift in the magnetic fields, and a change in the solar wind density and velocity. So it was pretty minor. And this second strong negative BZ signal up here with a total field of 9 nanotesla and a BZ of -8, that did indeed cause that brief period of geomagnetic unrest, which subsided rather quickly. So we could see that kick up again today, again because of coronal hole high-speed streams and the possibility of a CME impact. So it looks like NOAA's agreeing with us here. And yeah, maybe NOAA's watching the channel. Cheers. Shout out to the National Oceanic and Atmospheric Administration. Current conditions are a very diffuse solar wind here at only 1 proton per cubic centimeter. Solar wind speed here nominal at 401 kilometers per second. Next, we'll look at our GOES magnetometers. There are the readings from the GOES 16 and GOES 18 over the past 3 days. Fairly uneventful there. And it looks like the GOES 18, represented by that blue line, did a little bit of maneuvering around noon local time for the GOES 16, which is represented by that Those red N's and M's, those are noon and midnight local time for the satellites. Next, our top view ecliptic plane field plot. Earth is in a south pole current sheet, and we're expecting to stay here for the foreseeable few days. Sector boundary crossing is quite a few days out yet. There you go. There's the South Pole current sheet depicted in red. North Pole current sheet, again, several days out there, nearly on the opposite side of the sun at the moment. Next, our line of sight field plot here. The solar B field is in blue. North polar field in green. South polar field in red. Gong magnetogram in grayscale. And that brings us to coronal holes. Coronal holes are super important to the solar cycle. They show us the solar polar field reversal process. The coronal holes stay fixated around the polar regions at solar minimum. At solar maximum, they're typically straddling the solar equator. Those are the most geo-effective coronal holes, and we've got quite a few South Pole-oriented ones here rotating in from the east. So there's the last image. South Pole coronal holes here, especially in the north and the northeast. Western limb there showing some North Pole coronal holes. And here they are in the SDO 211 angstroms wavelength. It is one of the species of ionized iron, and it's the best at showing coronal holes. Some quite well-defined ones here rotating through. Next, it's time for sunspots. So let's cover those. Those are kind of important, right? So here's the Integrated Space Weather Analysis Center Solar Flare Probability Monitor and the Solar Flare Scoreboard. 3421 and 3417 have been the highest scoring sunspots as far as solar flares. We do have a high likelihood of large flares in the northeast. Several magnetically complex sunspot groups. So this new group that formed over here, that'll probably be 3425. This one up here will be 3426. Let's take a closer look at those from the SDO. And here we've put together, that's 131 angstroms, which is good at showing flares. You can see a bit of a simul flare happening there on either side of the Earth scale. Multiple regions there are likely to produce large flares at the moment. Let's subtract the 131 angstroms to show the continuum by itself to highlight that new sunspot formation. So here's one new sunspot growing, and here's one new sunspot rising. So this one I think already got a name. This one up here doesn't have a name yet. We'll see at least two new named sunspot groups. It is a solar uptick in progress. No real surprise there, as again we are still like a year out from solar maximum. And you can expect a continued uptick in coronal hole activity as well. That is sunspots for the past 24 hours from the SDO continuum wavelength. We also did have a minor solar proton event here, so a little SEP, solar energetic particle event. It was generated associated with one of the flares that happened right around midnight local time. Here's the GOES X-ray flux, and it was probably this impulsive flare right here that happened around just before midnight universal time there. Peak flux was sometime around 2340, it looks like. And let's take a look at our flare wavelengths. There you've got 94 plus 131 angstroms. It is another 24-hour video, by the way. So that's where the action has been. And let's look at something a little bit dimmer. The early morning sky here over Lehigh Valley, Pennsylvania. This is our star chart from skyandtelescope.org. You've got the third brightest object there and the second brightest object. Also Jupiter not too far away, the moon there near the Pleiades. By the way, if you're viewing the dusk sky, you see Mars soon after sunset. That is sometimes the fourth and sometimes the fifth brightest object, depending on its proximity and the proximity of Jupiter, which is setting in the west over the next about 3 hours. Next, our solar system forecast. Here's where things are today. Let's move this ahead 1 week. That's where things will be on the 13th. We will have a little thin crescent waning moon there as we approach the September new moon, my favorite phase. And check it out. Here's the astronomy picture of the day. So this is the Hess telescope, which is for measuring Cherenkov radiation, which is essentially gamma rays. So we won't spend too much time on that, but that is the apod.nasa.gov site, the Hess telescopes. And let's move to coronal mass ejections. It has been pretty significant. And as far as the available coronagraph imagery shows, while we do see halo eruptions, which are sometimes associated with Earth-directed CMEs, coronal mass ejections, these appear to be on the opposite side of the sun. So we don't think those are earthly directed. We think they're going the opposite way, which can be a little bit deceptive. That's 103 frames from yesterday. Unfortunately, we have no frames from today, but don't worry, we've got the Soho-Lascaux C2 and C3 together there. And let's take a look at those a little bit blown up. So here is 1436 on the C2 and 1530 on the C3. Again, it does look like a halo. It is a halo eruption. However, it's not an earthly directed one. Also around 2000 Universal Time last night, we saw a second CME. Also does not appear to be earthly directed. So some exciting looking events there. But those are not as exciting as they might appear. We'll also show stereo A just for some additional data here. Let's bring this one back. Difference imagery on the right, raw coronagraph on the left. And let's move these through. There is the one around 1500 Universal Time. It looks like a little missing data there, but great view of that one on both the difference imagery and on the raw coronagraph. Now let's move to our custom coronagraphs. And these really do make things clearer, folks. So these are 24-hour videos. You've got the SDO 193 angstroms in the middle, the Soho-Lascaux C2 in red, C3 in blue. And as we zoom in a little bit closer here, let's go to our next stage. You're not going to see any plasma motions associated with those CMEs. So typically 193 angstroms is going to show you some plasma moving around there. You'll see some evidence of rim darkening or something happening, an indication that those CMEs are indeed on the opposite side of the sun. So you can see a little bit of motion happening down here. We do regularly see events sort of rippling across the surface of the sun. In other words, sometimes we'll see a flare on the far side and it will equate to events on the Earth side and vice versa. Yeah, those CMEs do not appear to be earthly directed. They are on the opposite side. And here's 193 angstroms by itself. Now we've got massive filaments continuing to populate the Earth-facing portion of the solar disk. And since those often turn into coronal mass ejections, let's take a look at those from Udaipur, India. Now we put up a still frame here because there must be some clouds over Udaipur, India at the moment. So we just have a still frame here. But look at the size and the density of these filaments. I mean, there's 1, there's 2, 3, 4, 5, 6. I'm going to call that 1 for 7, 8, 9, 10, at least 11 significant filaments on the Earth-facing portion of the solar disk. Here's the grayscale. Again, we left that in a still image because it's cloudy. Here, I'll show you. You see, that doesn't look good. That's no good. But also a prominence up here around the North Polar region, so that's a crown prominence, and a prominence over here in the northeast, which I believe is still quite a likely place to see a large solar flare. And let's cut to our custom filament wavelengths. Yowzers. That is a sweet 24-hour video. That's ionized helium in 304 angstroms and ionized iron in 193 angstroms. So first we'll show the northern hemisphere. Great view of a lot of massive plasma filaments as magnetic fields suspend that material, defying gravity. And here you get a fantastic view of that solar polar vortex kicking off at the south polar region. It becomes a crown prominence, and then it violently spins around, and then plasma reorients, finally succumbing to gravity. Also, check out that filament just to the east of the Earth's scale there. We've got an extreme close-up of that just to show how huge it is. Check it out. That is one massive plasma filament indeed. So that's our last custom video of the day. And we're about to get the bonus features here. By the way, thanks to our new Twitter followers. We're frankly surprised you found us on Twitter, because free speech has not been repaired over there. It's just ridiculous. Ridiculous. Censorship continues on social media. It's evil. It's anti-human. And frankly, it's criminal. Here are the past couple of hours from the GOES 16 SUVi. And there is a solar flare watch in effect, folks. There are lots of places that we could see continued solar flaring activity. Lots of massive plasma filaments. So exciting stuff going on here. A big solar uptick. New additional sunspots showing up. Expect the radio flux to continue to rise. Expect coronal mass ejections to continue. Lots of stuff going on. Let's move to our bonus features segment. Here are charging hazards for satellites. We do have some minor surface charging there over Mexico and the Eastern Pacific. GOES electron flux here showing a moderate range there, just the normal nominal operating range for the GOES electron flux. There's the 1-year graph to put that in context. From solon.info/solar. There is NOAA's forecast for relativistic electrons, and just expecting to be in sort of a moderate range here for the coming days. We may see this dip way down if we do indeed see coronal mass ejection and coronal hole high-speed stream impacts. Moving right along to the layer where it's measured, the F layer of the ionosphere. one slice of the atmosphere. It's at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation penetration, and chemical concentrations. Here is the vibrational frequency of the ionosphere. And we are seeing that continue to subside following a mild geomagnetic storm condition a few days ago. So that is the vibrational frequency in megahertz, millions of vibrations per second. Here's the anomaly in megahertz from a 30-day median. And things are quite chill there. A mixture of mild blue and red on the most recent data. Again, an indication that things are subsiding from the scintillation caused by those geomagnetic storms. Here's the latest image, 10:45 universal time for the ionogram, 10:45 universal time for the anomalygram. Next, we'll show total electron content, which is literally a count of electrons. Your GPS satellite has to communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons cause signal refraction, and not only do they tell us about some aspects of space weather, they also tell us the most likely places for GPS errors. So that's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, the total electron content forecast. We show the global scale, and then we show a little bit higher resolution detail for North America as we zoom in closer and closer to the weather for the lower 48. So there is the total electron content anomaly from the 10-day average. We are seeing quite a few high electron count anomalies here. So here's some around northern Canada, some around the Great Lakes region and the northeastern U.S. And then some additional high electron content anomalies over Mexico, and then the Cascadia fault zone there around British Columbia. Pretty significant high electron content anomalies there. Again, that's anomaly from the 10-day average. Let's play that through one more time. And then we'll show the latest images of the closest star. There's the intensity gram. There is the colorized magnetogram. Let's put these on screen first. New sunspot groups up there. This one is beta gamma delta class. This one is beta gamma class, and this one is beta gamma delta class as well. So again, high likelihood of large flares, especially up here in the northeastern limb. These other groups have been producing some flares as well. That one looks like it's beta gamma delta class. And indeed it is. And this group up here is beta gamma class. So that's another new one. Again, 2 new sunspot groups to get names today. There's your solar rockback. And it's time for meteorology. Now, I discovered about 20 years ago that it's way too easy to forecast Earth's weather. So I bring it to you as a value-added service. If you enjoy the content, make sure you press like, subscribe, share, etc. Leave a comment, tell your friends and foes about the channel, and so forth. If you want to support the channel, become a member of the Smash Team at smashomash.com/Smash Team. These videos are brought to you in part by Gold, Silver, Smash Team members, as well as by Smash staff and I at massive personal risk and expense. So support the channel by dropping us a few bucks per month, or better yet, the best value is the Gold annual paid-up subscription. Thanks again to our Smash Team members. There's even a bronze level there that costs you $0 per month. Today's featured product is Do Not Pole Vault the Caldera. This public service message also brought to you at massive personal risk and expense by Smash staff and I. And save 40% site-wide. Yeah, 40%. You deserve it. So enter the promo code You Deserve It to save 40% on all Redbubble purchases. We have over 30 designs in dozens and dozens of different products. So, since our finest days lie ahead, don't pole vault the caldera. You could become part of the lithosphere. Don't become magma. Don't become lava. Don't pole vault the caldera. It could be unhealthful. And since our finest days lie ahead, if you're going through hell, keep going. Today's featured product on the Amazon shop is the Tao of Jeet Kune Do. The expanded edition features all kinds of cool illustrations by Bruce Lee, as this was a conglomeration of his notes that he took over years. He wrote a lot of notes when he broke his back, when somebody else broke his back, actually. And, yeah, the Tao of Jeet Kune Do, that's the featured product at amazon.com/shop/Smashomash. So that is our Amazon storefront. Check that out if you haven't. You can get spaceware, deals on spices, some supplements that I take. You can also find links to the Hemp Lucid shop. So we've got multiple paid affiliates/sponsors to increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. So if you are picking up CBDs, mushroom gummies, immune stacks, etc., pick them up through our shop. You can find links on the homepage at smashomash.com as well. And of course, below this video in the description. Smashomash.com is the official homepage of the Smash News Network, least busted name in news, because in 2019, a crack YouTube unit was sent to social media prison for a crime they didn't commit. They promptly escaped a maximum security social media stockade to the internet underground, where they survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you can certainly hire the Smash Team. You can certainly go to a website as you're viewing this video on the internet. Smashomash.com/Smash Team for additional content. And here comes the meteorology segment. Now, we do have some entrainment of dust in this new tropical system. So this system is expected to increase in strength. It has avoided most of this densest Saharan dust over here, and it is expected to be moving up here north of Puerto Rico in the coming 3 days. We'll show you some forecasts on that here in a minute. So that's depicting surface winds there and particulate. That would be the particulate optical thickness of 550 nanometers, so very fine dust will appear on that. The Saharan dust there blowing across the Atlantic Ocean, but it looks like it's largely going to avoid that. So we are expecting a significant strengthening of that system. Again, we'll show you forecasts here in just a moment. First, we're going to show you what's going on in terms of wind patterns around planet Earth. So here are the surface winds on the east. The east side, strong onshore wind there at the Bay of Bengal. Here are the jet streams of the east. We do have this upper level anticyclone here continuing just to the northwest of Australia there. That counterclockwise rotation indicating a high pressure upper level system. Anticyclones rotate counterclockwise in the southern hemisphere. Next, jet streams of the central world. There you go. Surface winds of the central world depicted here. That's Africa, Europe, and the Middle East. Surface winds of the west. Again, that low is going to strengthen into a legit hurricane in the coming 3 days. Again, we'll show you forecasts. Here are the jet streams for the western world. All right, so here's the first forecast. We're looking at wind right now. And if we advance this 3 days, you're going to see that system strengthen. It's going to grow. And the wind speeds are going to pick up. So there we are at Saturday at 2 p.m., 1400. That is the Euro model. The GFS model has it getting even stronger. A little bit larger, but around the same location there. So there's the Euro model. That's Saturday at 2 p.m. And that is 1800 Universal Time, if you're wondering. 1400 Eastern Time. That's our local time here in Lehigh Valley. 1800 Universal Time. On Saturday, the Euro forecast, and there is the GFS forecast for that same period. Next, clouds and fog over the Americas. As we zoom in closer and closer to the lower 48. Here is our weather.gov map. So excessive heat, the heat wave continues in the Northeast. There is the key. If your location is lit up on the map, head to weather.gov and get your weather alerts. Those are too many counties, and those are air quality alerts because of smoke. So here is your smoke map from firesmoke.ca. And some heavy smoke here rolling down through North Dakota, across the Great Plains, South Dakota, Minnesota. Going to see some quite smoky air there from Canada. So that is the smoke forecast. Here comes that is your temperature anomaly forecast. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, your pressure and precipitation forecast. The same model, the 72-hour GFS model. And here's the forecast for the North Atlantic. So you can see the pressure is going to be dropping all the way down to the mid 940s there, 946 millibars of pressure there for that low there as it moves up north of Puerto Rico in the next 3 days. That's what's going on in the North Atlantic. Next, lightning. We did have a string of lightning here stretching across most of the central U.S., all the way from Lake Superior down into central Texas. The heaviest lightning was across southeastern Missouri. And do we have any terrestrial strikes here? Indeed we do, around Lake Michigan. Some around Chicago, some around Memphis. That is where the lightning strikes are currently occurring. Next time you hear thunder, check out lightningmaps.org. I highly recommend it. There's a full 50-state view of Doppler radar, some precipitation across Alaska. Let's briefly take a look at these strong storms here. Check it out, strong storms there. South of Chicago. So there's the lower 48. Doppler radar depicts vertical motion in the air column. Shortwave radiation depicts clouds and fog when it's too dark for the visible satellite, and the water vapor map shows all of the water vapor. We've got an upper level low over here, but it's entrained with dry massive air, so not a lot to that. And one other quick note about that Atlantic system. So here we're showing wind and sea surface temperature, and there is a lot of hot water. So check it out, this water up here, 86 degrees there. So plenty of convective capability there, as hot water tends to fuel hurricanes. So here comes a recap. That's U.S. Doppler radar. There is clouds and fog. And there is water vapor. That's where we'll have to close this thing out. Anyway, thanks for tuning into the Smash News Network, least busted name of news. Congratulations on realizing the channel exists. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.